Welcome back, students. In this video, we're going to look at a reaction and decide whether or not it's going to proceed via an E1 or an E2 mechanism. When we're looking at an E1 or an E2 mechanism, we're going to look at a couple of ideas. We're going to consider the substrate, which is the compound that the leaving group is attached to. We're going to consider the base, and of course, we need a good leaving group, so we just have to make sure that we have one. For E1 reactions, you need a hindered substrate. You need something that's going to form a stable carbocation. So that's the requirement here, is that we form a stable carbocation. The thing about E2 is it doesn't actually matter if you have something that's primary, secondary, tertiary. Hindrance doesn't matter for E2. As long as you have a beta proton and a strong base, your E2 reaction is going to happen. If we look at this table down here, methyl, primary, secondary, tertiary, allylic, benzylic, how do we know if an E1 or an E2 is going to happen? Well, E1 requires a stable carbocation, so it's not going to happen for methyl or primary. It can happen for secondary, it will happen for tertiary, and allylic and benzylic make good carbocations because they're resonance stabilized. Even if it's primary allylic or primary benzylic, they're still going to form good stable carbocations. Whereas E2 is not going to happen for methyl because you don't have a beta proton, so that's not going to occur for either. E2 will happen for primary because you have a beta proton, right? As long as you have a beta proton. Secondary, it'll work. Tertiary, it'll work. And as long as there's a beta proton to abstract, it will also work for allylic and benzylic. When we're looking at our bases, your E1 requires a weaker base, whereas the E2 requires a stronger base. What happens in E1 reactions is the leaving group leaves on its own and forms a carbocation, and then that carbocation is super reactive, so a base can come in and pull off a proton really easily, even if it's a weak base. Whereas for E2, think of it like you have such a strong base that it's not patient enough to wait for the leaving group to leave. So what happens is your impatient and strong base just goes in and pulls off a proton. It doesn't wait for that leaving group to leave. It says, I'm too strong, I'm not going to wait for that, and then forces the reaction to happen. Here's a table that we're going to start using when we begin looking at how SN1, SN2, E1, E2 all interact with one another. Because if you haven't quite figured it out yet, there's a problem. E1 and SN1 have the same first step. So that means that it could go either way. So here's the table that you need to start working on committing at least part of to memory. We need to remember which compounds are going to behave as a nucleophile only, because if something is only a nucleophile, then you're expecting only substitution reactions. If something is just a base, then you're expecting only elimination reactions. If a compound is a strong nucleophile and a strong base, then you're going to expect substitution and elimination to compete with each other. And then finally, weak nucleophile and weak base, again, you're going to expect substitution and elimination to compete with each other. For E1 and E2 reactions, you still need a good leaving group because the leaving group has to leave at some point. So just keep in mind, remember what our strong leaving groups were. Our good leaving groups were things that were conjugate bases of strong acids. So things like chloride, bromide, iodide, water, and then recall that the OTS was the tosylate ion, and that's back in one of our earlier videos. Let's wrap up. In this video, we looked at the substrate, and we said that for E1 mechanisms, you need to have the ability to form a good carbocation, a good stable one, in order for the reaction to happen. Whereas for E2, there was no hindrance requirements, but you did need to make sure that you had a beta proton. For your base, your E1 reactions are going to use weak bases, your E2 reactions are going to use strong bases. When you have these reactions, you have to make sure that you have a good leaving group, or else the reaction will not occur. Thanks so much for your attention. This is Katoni signing out.